Okay, in this presentation we are going to look at continuous random variables. What we have here is a probability density function. The density function of x is given as follows. So here we have the probability density function of x, small f of x, and that is equal to a plus bx squared, where x is between 0 and 1 and 0 otherwise. Okay, so this is important when we do definite integrals as part of our calculation. This is the upper and lower limit of the definite integral, 0 and 1. If the expected value of x is 3 over 5, find a and b. Now a and b are constants, they're real numbers. Okay, so this is the general definition of the probability density function. Okay, so between the upper and lower limits, now you sort of assume until otherwise told that it's minus infinity to infinity, but if you are given specific limits of integration, you can actually just replace them with what you're told here, because this is the only place where it makes sense. So the probability density function, if you integrate that from the from the lower limit to the upper limit, okay, the value should, by definition, be equal to 1. Otherwise, it's not a legitimate probability density function. Okay, so that's what we're going to use. We're also going to use the fact that the expected value of x is calculated in a similar sort of way. It is the integral from minus infinity to infinity, or alternatively, the lower limit to the upper limit of x times f of x dx. Okay, and we know that's going to be 3 over 5. Okay, so essentially what we have here is two definite integrals, and we know what they should solve to be. So what we can do is deduce what a and b are based on these two definite integrals. So in the first case, what we do here is we evaluate the probability density function, and we can replace minus infinity infinity with 0 to 1 as the range of possible values of x. Okay, dx, and that is equal to 1. Okay, so let's evaluate this. So when we integrate this out, it's a straightforward enough integration. What we get there is a definite integral, ax plus bx cubed over 3, evaluated between 0 and 1. Okay, so when we evaluate that expression at x equal to 1, we get a plus b over 3. And when we evaluate it at 0, essentially what we get is 0 plus 0, so we can just disregard that and concentrate on a plus b over 3. So a plus b over 3 must equal to 1. Okay, so that is going to be the first part of our calculation. Okay, the second part here is as follows. We do the same thing. This is the expected value of x. Okay, and that is a definite integral between 0 and 1 of x times a plus bx squared, and that is equal to 3 over 5. Okay, so when we calculate this out, essentially we multiply it through ax plus bx cubed, and when we integrate that, ax integrates to ax squared over 2, and bx cubed integrates to bx to the power 4 over 4. So that's our definite integral. And what we do is, again, evaluate it between 0 and 1. And again, when we evaluate it at 0, we just get minus 0 plus 0. So we can just disregard that. Always check that, though. Don't assume that if the lower limit is 0, that necessarily the expression is trivial. Just check it true. But anyway, what we get there is a over 2 plus b over 4. Okay, and we know that to equal 3 over 5. Okay, so a over 2 plus b over 4 equals 3 over 5. What we can do is just simplify the expression, and we have a plus b over 2 equals 6 over 5. So essentially what we have here, just multiply it by 2, just to simplify things. Okay, so what we can do now is we have the first expression here, or a plus b over 2, that's actually the second expression, and that is equal to 6 over 5. What we can do is subtract the first expression from that. A plus b over 3, which is equal to 1. So essentially subtract one expression from the other. Simultaneous equations, essentially. Now the a values cancel out, so what we're left with is b divided by 2 plus b divided by minus b divided by 3, and that will equal 1/5. Okay? So that means that b over 6, which is the difference of the two, b over 2 minus b over 3 gives you b over 6, and that is equal to 1/5. that means that b is equal to 6 over 5. So if that is equal to 6 over 5, a plus b over 2 is equal to, just to sum up, b is equal to 6 over 5. Now previously we were told, or we figured out that a plus b over 2 is equal to 6 over 5. Necessarily, that means that a is 3 over 5. So let's just check this through. So we have a equals 3 over 5, which is 3 over 5, plus b over 2, which is 6 over 5 divided by 2. That is also 3 over 5, and that gives us 6 over 5. Okay, so that checks true with what we have here. Okay, so to sum up, a is equal to 3 over 5 and b is equal to 6 over 5. You can check it with the other expression there as well. A plus b over 3. What does that give us? That gives us 3 over 5 plus 2 over 5, and that is equal to 1. Okay, perfect. So that checks true for both of the simultaneous equations. Okay, we'll leave it there.